All right, first bullet. Perfectly competitive firm, PC firm, takes the market price as fixed, knowing that changing its quantity, Q, cannot affect the price. If that's true, which we're going to assume now, it's going to be true that the marginal revenue in the market is going to be just equal to whatever the market price happens to be. Why is that true? Well, the slide below is going to show us. But first, I want to highlight one little adjustment I'm making. Instead of calling the quantity capital Q, I'm calling the quantity for an individual firm little q. And the reason I'm doing that is to emphasize the diminutive nature of production of an individual firm. A firm is as small and tiny compared to the market as a whole. The capital Q will be used to represent the big market, where lots and lots, maybe millions of the goods are being produced and supplied, while little q is going to refer to just thousands of units that are being supplied by an individual firm. Okay, so come down here and imagine that Q represents the amount that's being produced by an individual firm, and that firm knows that it can bring the product to the market and it's going to be able to get the price P bar. And the bar is indicated, often use bar to represent a variable that's fixed in value, that isn't going to change. So if they bring Q1 to the marketplace, let's say, then they're going to be able to sell the product at the price P bar, and as a result, they're going to get this red area, this rectangle, as the total revenue that they're going to be earning. And that's what's given here in this first total revenue situation number 1. Okay, but if quantity goes up to Q2, then they're going to actually get revenue equal to Q2 times P, which is going to be equal to the area of this yellow rectangle instead. And notice that we can calculate the changes in revenue, total revenue, given the change in quantity. That is, we can do the calculation for marginal revenue, and it would look like this. Take the new value, P bar Q2, minus the old value, P bar Q1, that's the difference up here, divided by the total quantity change, which is Q2 minus Q1. Well, if we did that, since it's the same price being multiplied by the two quantities, we can factor out the price P bar and write this as P bar times Q2 minus Q1. And then we're dividing by the change in quantity, which is Q2 minus Q1. So these are going to cancel out, and we're going to be with marginal revenue is equal to the price P bar. So if you're not moving down a demand curve when you increase your quantity, and the small firm is assumed not to be, then you're going to get this fixed price, and that's going to mean marginal revenue reduces to, or simplifies to, not a downward sloping line like this, like we had said before. Instead, it's going to be a straight line given by the price that prevails in the marketplace for this individual firm. So you see here how we're going to end up using exactly the same diagrams as we did with a monopolist, for example, but because we're changing the assumption about the size of the firm and how it can affect or not the price, it's going to change the way in which we interpret and what we have to look for on the model itself. All right, so this is an example where we're using a bunch of the same assumptions. Cost curve is U-shaped, marginal cost is upward sloping, crosses at the minimum. All of those assumptions are going to be same as if we're in a monopoly or if we're in perfect competition. But because of the small firm assumption up here, it's going to change the way in which we analyze that particular diagram. All right, and that's going to be important to take note of. Now, a profit maximizing, perfectly competitive firm will choose their output level to maximize their profit such that it satisfies the following condition. And this is one you have to remember. Price is equal to marginal cost. So choose output such that price is equal to marginal cost. That's what a firm has to do if it wants to get the most money it can in the market situation that it faces. All right, now this is similar to, and what I want to highlight is that what we just showed in the previous slide is that marginal revenue is equal to price, the assumptions we're now making. So this condition, P equals marginal cost, is really marginal revenue equals to marginal cost, except that marginal revenue has become the price under the assumption of perfect competition. So marginal revenue changes its nature in perfect competition relative to monopoly. Okay? Instead of the marginal revenue itself, a curve we're just going to set it equal to the price itself that prevails in the marketplace. Now, one highlight I want to emphasize to you. If I asked you what's the profit maximizing condition for a perfectly competitive firm, it's not incorrect technically to say marginal revenue equals to marginal cost. Okay, that's technically true. But I don't want you to give me that answer for the perfectly competitive firm. I want you to give me the answer that's highlighted here in the middle, P equals marginal cost. Because there's an adjustment that's being made under perfect competition that I want you to be aware of. So while this is technically true, marginal revenue equals to marginal cost, you should be giving the more narrow definition of the condition, which is price equals to marginal cost. Here's how it's going to change the way we evaluate the diagram itself. Okay, look on the left-hand side. The left-hand side has got a hand-drawn diagram with a monopoly. Okay, I've got a capital Q listed here. And notice I'm indicating that we're talking about a big market for this individual product, something that's being used in quantities of millions. So maybe this Q1 is something like 2.5 million units or something like that. Okay, and it's also, notice that average cost is coming down for the monopolist as we're increasing output from 1 million to 2 million to 3 million and so forth. So the minimum average cost over here, might be at a level of, tens of millions of units of this individual product being supplied to the market. And if there are these economies of scale, this downward slope to the average cost curve for large amounts of the good, we might have a case to be made that this is indeed a natural monopoly, that it just makes sense to produce the product in large quantities rather than in small quantities because it's more efficient to do so. But now let's jump over to the right. Now we've got a quantity that's listed in thousands only, small, much smaller than the millions listed on the left-hand side. I have an average cost curve that's U-shaped, just like before, and a marginal cost that's crossing the average cost right at the minimum conditions that we had identified before. Okay, but the quantity where this cost is minimized is now in the thousands, not in the millions. And so in essence, that average cost curve is really drawn like way over here in a very small number of units. Okay, it comes down and goes back up. So this is a situation where there wouldn't be a natural monopoly that could just increase its production to millions and lower its cost relative to other firms. Instead, it's saying that actually minimum cost of production can be achieved at a relatively low output. And then market demand might be several thousands or tens of thousands times bigger than what an individual firm could produce. And so it's conducive to having many, many, many firms producing a product in the market, each of them minimizing their costs of production in order to achieve that result. Now, down here on the left, the monopolist is going to set marginal revenue equal to marginal cost. The perfectly competitive firm is going to set price equal to marginal cost. So they're going to take the market price from the market, which, by the way, we have not determined where that's coming from yet. But we're going to imagine that the firms know what the market price is, take it as given, and then what they're going to do is draw a straight line bar across for the price and set it, identify it as marginal revenue as well, find where it crosses marginal cost, which is right here, and that's going to determine the quantity that the individual firm produces. All right, so that's the difference. Notice we're looking at marginal revenue downward sloping here, marginal cost here. That's how we're finding this condition. But on the right-hand side, perfectly competitive firm, we're looking at a horizontal line and where it crosses marginal cost to determine the quantity. All right, and so that's how we're changing. Also notice that this graph is not looking at the entire market. It's looking at just one firm amongst many thousands of individual firms who are presumed to look exactly the same way because they all have the same cost of production. Now, if we wanted to calculate the total output in millions, we would have to take capital Q would be equal to the summation from the first firm up to the nth firm, where N might be tens of thousands of little farms producing wheat. Okay, we add the quantity that each of these individual farms are producing, and that's what's going to generate the total market production or output that's being supplied to the market in total. All right, more on that next week when we talk about the derivation of the supply curve for these individual firms. Okay, so that's a little bit of the distinctions between the two. What we're going to do next is go back to our broom factory example. And this was the example we used to derive a set of cost curves for an individual firm. You will remember that we had a demand function that had output levels that changed in this particular way. And remember, we had actually labor input that was included, and we said 0 workers, 1, 2, 3, and we were able to produce this particular output with different amounts of inputs of labor. Okay, well now we're going to keep that same output schedule, but we're going to change the measurement of these individual cost components by virtue of the fact that we're now talking about a small representative firm that faces a fixed market price and has to just go with that, take the prices given and work with that. So here's the output schedule as before. And we're going to imagine that on top of that output schedule is the price or marginal revenue, because they're equal to each other under this assumption. And we're going to just make an assumption that that price is $10. So this supposed is an added assumption we're now adding to this market and saying, let firms wake up, go to the market and say, oh, look, everybody is selling the product at the price of $10. That means they can sell 20 units if they decide to produce it at $10. Or they can sell their 50 units at $10 each, or 90 units at $10 each. So $10 becomes the price they're going to receive regardless of how much output they produce. And this is what's different now from the previous display. In the previous display, in order to produce or sell more output, you had to lower the price that's being prevailing in the marketplace. But now, again, these outputs are little compared to the market, and therefore the firm can sell everything at the price of $10. Total revenue, next column, is just found by taking price times quantity. So we've got the price right here, we've got the quantity right here, multiply these two together to get the 0, 200, 500, 900, and so forth. Now, let's take a look at total cost, and we're just picking this up from the cost functions that were before. And notice that the total cost here at quantity 0 is equal to 200. And that's got to mean, I don't have it written up here, but I should, that the fixed cost, like before in our previous example, is equal to $200. And we imagine that the marginal cost of a worker, the amount of money we have to pay the worker, remember 0, 1, 2, 3, is going to be $100. So the variable cost is equal to $100 per worker. And that's going to give us the 200, 300, 400, 5, 6, 7, this total cost function. So we add on no workers at 0 here, so no, but one worker at $100 plus the 200 fixed cost is going to give the 300, and so forth and so on. So that's where those numbers are coming from. Now, to calculate profit, you're going to take total revenue, and you're going to subtract off total cost. So this last column is just the difference between those two columns. 0 minus 200 is minus 200. 200 minus 300 is equal to minus 100, and so forth and so on. We get the profits that the individual firm make at different levels of output. Okay, and lastly, we want to measure the marginal cost. Okay, and the marginal cost, again, is the change in total cost given a change in output, which is this column right here. And this is going to be the same as we had displayed previously in the broom factory example. Marginal cost starts out high, falls to a minimum, and then rises back up as output increases along this particular scale. Now notice that we don't have an equal, we don't have 0, 5, 10, 20, 30, and so forth. We don't have all the numbers listed here for output. We just have a selection of them, and they're not equally spaced along output. So when we calculate profit, we're going to end up maybe missing exactly where the maximum profit is going to be. But we do have a condition where we can see here that marginal cost rises up to $10, and that's where it's going to be equal to marginal revenue of $10. So that's going to give us the hint of where profits are going to be maximized. It's going to be right here. It's at output of 150 units, a price of $10, that's the market price, and a profit of $700, which is the same as up here, So maybe in between these two is really where the output maximum is going to be. Or again, because I've shifted these down in writing them, this is actually describing someplace in between the two output levels or something like that. Okay, but if you find price equals the marginal cost on the chart or the table, go ahead and identify it, and that should turn out to be at least one of the maximum profits that you can display on the profit graph over here. Okay, so there's our answer. That's how we can kind of conceptually, or using the numbers, we can figure out what the profit maximum would be for an individual firm. But let's do it diagrammatically. Okay, here we have an example, not exactly graphed like the numbers before, but styled in exactly the same way. We have a U-shaped average cost curve listed here. We've got a U-shaped marginal cost, but the U comes earlier, and the marginal cost crosses the average cost at the average cost minimum. That's always a feature of these sorts of cost curves for an individual firm. Okay, now, the price at P star. P star before is what we said was $10. We're going to take that $10 and we're going to find the quantity level that's going to set that price equal to marginal cost. That's going to give us a quantity from the numbers before. What was that quantity? 150 units. So matching up what we had before, that Q star is going to be at 150. All right, now from the graph, we can now visualize the following data or information. Okay, so first, find the price, find where it crosses marginal cost, carry that down to the quantity axis to determine the quantity that we needed to maximize profits for this individual firm. Okay, next, what's the price going to be in the marketplace? Well, we're already given the price. We know the price is going to be P star. We know the quantity maximizing profits is going to be Q star. So total revenue, the first bullet here, is going to be given by P star. Remember, is this distance, because that's 0 down here. So P star represents the distance on the vertical axis right there. And Q star represents the distance of this horizontal axis right there. And since the total revenue is equal to P star times Q star, it's going to be equal to the area of this rectangle. That's going to be total revenue earned by the individual firm. Next bullet, total cost. To calculate total cost, you have to take the quantity Q star, carry it up to the cost function, average cost function right here, and carry it over to get average cost. Notice I'm mentioning that average cost at Q star is equal to AC star, which is what I'm measuring here on the left-hand axis. All right, so now total cost is equal to AC star, that's this vertical distance right here. And I'm going to multiply it by Q star, which is this horizontal distance right there. So therefore, this area corresponds to total cost. Profit. Well, profit is nothing more than total revenue minus total cost. And if I take total revenue, these equations right here, I'm going to note that I've got P star times Q star, and I've got AC star times Q star. I can factor out the Q star, and I could then make it price minus average cost at Q star times Q star is going to give me the profits that the firm is earning. Now, price is up here. Average cost is there. So this distance represents the distance between price and cost. The quantity is measured along this distance right here. And so profit is going to be given by the area of this rectangle right there. So the firm, in this instance, is going to be making positive profits in the marketplace because its revenues exceed its costs of producing the quantity Q star worth of the good. Okay, so that's how you calculate quantities, prices, revenues, costs, and profits for an individual representative firm in a perfectly competitive outcome. This happens to be the case, though, where profits are positive. All right? What we're going to do next is we're going to take a look at other circumstances that could arise if the firms face a different price from the one that I've just posted. Okay, next example. Case 2 is going to be the case of negative profit. And to do this example, we're going to use exactly the same output, exactly the same total cost function as before for the individual firm. That's going to give us exactly the same marginal cost as before. So we have exactly the same assumptions on cost sides as before. But what we're changing is the market price. And we've lowered it now to $3.33 from $10, much lower than before. And we're going to see what the impact of that's going to be. Now, if the price is 3.33 from the market, then that's going to be the marginal revenue. So everywhere, marginal revenue is going to be $3.33 for this small individual firm in the marketplace. Okay, and that means we're going to take, to get total revenue, we're taking the price, which is 333 up here, and we're going to multiply it by the quantity to get the total revenues, which is listed here. That's what I was trying to get at. Okay, and then marginal revenue is just going to be the price all the time by assumption. And then we can look at the graph, just kind of find, well, where is the marginal revenue or price equal to the marginal cost? And it's going to take place right here. Now, there is a problem on this particular chart that you will notice. Why not pick this 3.33 and this 3.33? Well, look at the profits over here. When we actually do the calculations, we're going to find the total revenue minus total cost is minus 200 in the first instance, minus 233, minus 233 again, minus 200, which is higher, and again up to minus 200. So profits fall, and then they rise back up again to a higher level. Remember, a smaller negative number is better than a bigger negative number for an individual firm. This means fewer losses are obtaining here. Okay, so why choose the second one and not the first one? The reason has to do with the depiction of it. Let me show it here. Okay, so here we've got a graph, and the price here is going to be the 3.33, and the quantity, I'm going to suggest, is going to be found in the second intersection between marginal cost and marginal revenue. And in fact, it has to be at a place where marginal cost crosses marginal revenue from below. So notice, if we were at, let's do this. If we were at, the firm was producing at this level of output, call it Q bar, I'm sorry, Q hat. At this particular level of output, marginal cost is greater than marginal revenue, and that would mean an increase in quantity is actually going to add more to cost than it adds to revenue. And that means increasing in this way is going to cause profit to go down. So as we increase quantity to this particular point, profits is going to reach a minimum. When the marginal cost crosses the marginal revenue in this direction, profits are minimized. When marginal cost crosses marginal revenue in this direction, rising up, then notice, if we were at this particular quantity level, then an increase in quantity is going to raise revenue, that's marginal revenue, more than it raises cost, that's marginal cost. And therefore, an increase in this direction is going to cause profits to go up. So that's why the first intersection of marginal cost and marginal revenue isn't the relevant one. It's the second one that matters. Another kind of tricky point to keep track of and remember. Now, let's take a look at this graph, see how this is informing us. Price is now set lower, P star. Notice that P star is crossing the marginal cost right here. And so to maximize profitability, you're going to take the price in the market, take a horizontal line, that's marginal revenue, find where it's equal to the marginal cost, and that's going to determine the output level Q star. So output level Q star is such that price is equal to marginal cost. Next bullet. At Q star, we can calculate what the cost is of Q star. To do that, we carry the quantity up to the average cost curve and carry it over to determine a value, AC star. All right, so quantity, average cost at the quantity Q star can be written on the left-hand axis as AC star. All right, now total revenue is price times quantity. So it's going to be this distance times this distance. And notice I got rid of the time sign. I can write these together, PQ, and that means multiplying the two together. All right, if I take P star to Q star next to each other, it means we're multiplying together. AC Q star, multiplying it together. All right, revenues in total are going to be equal to this down here. Okay, what about costs? Costs are average cost times quantity. Average cost is given by this distance. Quantity, again, is given by that. So the green rectangle is going to correspond to total costs. Profits. Profits are equal to price minus average cost. But notice the price is lower than average cost. So we're going to take the area up here, and that's going to be equal to profits, except it's going to be negative in value because price is less than average cost of production. So this is going to be a situation, a display of that, where there are losses being made by the individual firm. They're losing money in the marketplace if they produce Q star. And notice from the numbers here, the maximum profit is negative. The best the firm can do is to lose money, but even if it loses money, it means that they might still produce, but they're just going to, they want to maximize their profit, but maximization of profits might mean picking the lowest, I guess the largest number of the negatives. So a smaller negative value is better than a larger negative value, right? And that could be what maximizes profits, as it does here. Okay, next step. We'll do it again, one more time. Question. Based on the chart, the only way for the firm to earn profit rather than lose is to raise the price. Firm can't raise the price, though. Here's one of the assumptions we're making here. The firm is powerless to affect the price. They just take the prices given. So they can't change their price of the good in a perfectly competitive market. This is a hard assumption to remember and to keep track of because you normally think about firms having the capability of adjusting their output and their prices in the marketplace. But that is not true under the assumptions of perfect competition. Firms cannot change their price. They just take it as a given and they have to go with it. Now, where does it come from? Next class, we're going to talk about where that price comes from and how they make a decision about that. Okay, case 3, zero profit. Now we're just duplicating what we've done before, but I've changed the price again, and now the price is going to be set at $5 rather than 3.33 or 10, which were the previous two examples. Okay, now price is equal to marginal revenue. That's going to be equal to this $5 as before. Okay, and the output is the same, and the cost structure is the same, and total revenues are going to be found by taking the price 5 times the quantity. That's going to give you the values here, so forth and so on. Now, we're going to find where marginal revenue equals marginal cost. That's going to happen, again, in 2 places. Here, don't pick this one. Pick the second one, 5 and 5. And that's going to give a profit maximum, which is not very satisfying, maybe. A profit maximum of 0. So this is zero profits. They're not making any extra money as a result of producing 140 units in the marketplace here. All right, and here we're going to get back to this sort of notion of economic profit versus account profit. But let's look at the situation first in detail. So first, zero profit outcome in perfect competition. Now we've raised the price back up, and again, the firm doesn't have the ability to control the price. They can only take what's given. So we're imagining sort of different things going on in the big marketplace, changing the price, and then seeing how the firm responds to that price. This is not an exercise where we're going, let's let the firm change the price from 10 to 3.3 to 5. The firm is not changing the price. It's being changed by some other mechanism there. And the firm is only responding to whatever the price it takes from the marketplace. Okay, so we're imagining it takes different prices from the marketplace. That's very important. All right, to maximize profit, again, we're going to find where the price, P star, is equal to the marginal cost. That's going to occur at Q star right here. And notice we have actually get to a point here where that intersection with marginal cost happens at the intersection of the marginal cost and the average cost curve. By doing that, by showing that depiction, that Q star carried up to average cost means that average cost now is going to be exactly equal to the price in the marketplace. Okay, so when we plug the values in, we're going to get total revenue. Well, total revenue is going to be given by this area right here, total revenue. And total cost is also going to be given by that area. So that's going to be equal to total cost. So total revenue and total cost are going to be exactly the same area on the graph, and that's going to mean that profits have now been driven to zero. There are no profits. All right, now, one might imagine that this is going to mean that the firm doesn't make any money, so why should it be there? Why should it even be producing in this particular marketplace? Well, we're going to consider that particular situation next time, and we're going to ask, under what circumstances will the firm want to continue to produce even if its profits are zero? And that answer is going to depend on what its alternatives are. It's going to depend on looking at the opportunity cost of what it would do, what would happen if it were to shut down its plant and just stop producing. Now, you might say, well, they'll just make no money in that circumstance too, but we're going to see that the answer is a little bit more complicated than that. And that there will be plenty of reasons why a firm might choose and would choose to produce even though its profits are driven to zero. And here too, when we really say this in economics, we're going to imagine that firms can produce at zero profit. We're thinking of this now in terms of their economic profit. It's going to be like, this is the best they can do because there's no better alternative out there. And we're going to imagine that if this is like a firm where you're the owner and you're providing, you're trying to make profits for yourself, yes, but you can build into your cost structure the cost of paying yourself a salary. And you should do that as a firm. So even though you're sort of trying to make extra money to supply your family, that is your income. And there is a certain income that you're willing to accept in a production process. So in other words, that income you pay yourself as a small business owner, for example, would be measured as profit, but would be a part of actually economic costs if evaluated sort of completely or appropriately. All right, and that's why you can still make zero profits and still be succeeding as well as you could do otherwise in a marketplace. So zero profits is not a death toll for a firm. And in fact, it's going to turn out to be a just acceptable kind of situation in most circumstances for firms.